In this video, we're going to look at question 2 from tutorial 7, part A from the LO2 course notes, and you'll find this on page 21. So here we're given a question where we're relating linear and angular motion. We're told a cord is wrapped around a pulley, which is 63 centimeters in diameter, and asked to calculate the angular velocity in revs per minute if the rope is pulled off the pulley at a speed of 2 meters per second. And sometimes it's helpful to draw a little diagram in order to visualize what's going on here. So the pulley could be going horizontally, vertical, or an angle, but we've got a circular pulley here and a rope attached to it, and the rope is pulling at 2 meters per second. The diameter of the pulley, 63 centimeters. So this is information we're given in the question. We're asked to find the angular velocity of this pulley as it turns. So let's state what we know. We know our diameter is 63 centimeters, which if we're working in meters is 0.63 meters. And here's the test, the first test for us. We're not interested in diameter. We use the radius in these calculations. So that will be 0.315 meters. So make sure we're working with the radius. Start's important. Another thing we're given is the velocity of the rope, and that's 2 meters per second. So I think we've got the information we need to get started. So we've got linear motion, and we're translating it into angular motion. So we use our bridging equation. The bridging equation for our velocities is v is equal to omega times r. So we know v, that's 2. We want to find omega, and we know r, that's 0.315 meters. So rearranging, we have omega is equal to 2 divided by 0.315, and that is equal to 6.349, that's a 3 decimal place, 6.349 radians per second. So good, we've worked out the angular velocity, but this isn't in the form we're looking for. What we've been asked for is the angular velocity in revs per minute. So remember, if we're converting radians per second into revs per minute, we do the reverse. So if we have this formula here for when omega's in radians per second and n's in revs per minute, the formula we're going to need to convert the other way will be to multiply omega by 60 and divide by 2 pi. So in this case, our n value in this formula is the our omega value in this formula is 6.349, and the n is what we want to work out here. So if we have a look at this, we get 6.349 is equal to 2 pi n divided by 60, and so n is equal to 6.349 times 60 divided by 2 pi, and that gives us our angular velocity in revs per minute, and that works out, we put it into our calculator, as 60.6 RPM, and that's as concluded what we needed to solve for that question.